Hello friends, I am Rajjat Raypure and I will give the presentation on the topic encoding and decoding of message data and the process addressing. So in message passing, the message data should be meaningful to the receiving process. Means structure of program objects should be preserved while they are being transmitted from sending process addressing space to the receiving process address space. In heterogeneous system, this is not possible to achieve, but we can achieve it in the homogeneous system. In heterogeneous system, this is not possible as the processes are on the different computer architecture. In homogeneous system, it is difficult to achieve for the basic two reasons. An absolute pointer value loses its meaning when transferred from one address space to another. Therefore, program objects used absolute pointer value cannot be transferred in their original form, and some other form of representation must be used to transfer them. The pointer to the tree or the linked list is an absolute pointer. Second, a different program objects occupy varying amount of storage space. There must be some way for receiver to identify which program object is stored where in the message buffer and how much space each program object occupies. Due to the problems mentioned above in the transparent program objects in their original form, encoding and decoding is done. So encoding. Encoding is a process of program objects converted into stream by the sender. Program objects are first converted to the stream that is suitable for the transmission and placed into the message buffer. This process of conversion takes place on the sender side. Decoding. Reconstruction of the program objects from message data is the decoding. The encoding message, when received by the receiver, must be converted back from the stream form to the original program objects where before it can be used. This conversion takes place on the receiver side. One of the following two representation may be used for the encoding and decoding of message data. First is tag representation and the another is alt tag representation. In tag representation, type of each program objects along with its value is encoded in the message, and here the quantity of data transfer is more, but the time taken and encode to decode the data is much more. In this, it is simple matter for receiving process to check the type of each program objects in the message because the self-discovery nature of the coded data in the format. Second, untagged representation. In untagged representation, the message data only contains program objects. The receiving process must have a prior knowledge of how to decode the received data because the coded data format is not self-describing. No information is included in the message data to specify the type of each program objects. No matter which representation is used, both sender and the receiver must be fully aware of the data coded in the message. Here, sender have a encoding routine and the receiver have the decoding routine. Second, here another important issue in message-based communication is addressing of the parties involved in the interaction, to whom sender wish to send or from whom receiver wish to accept. For flexibility, a message passing system usually supports two types of process addressing. One, explicit addressing, and second is implicit addressing. So first, explicit addressing. In explicit addressing, the process with which communication is desired is explicitly named as parameter in the communication primitive used. So here the communication primitives for this explicit addressing is send a message to the process which is identified by the process ID. The here the message is the actual data and the process ID is the destination of the process. Second, the receiver message from the process is identified by the process ID. Second is the implicit addressing. In the implicit addressing, a process willing to communicate does not explicitly name a process for communication. Here the communication primitives are send a message to any processes that provide a service of type service ID. Here sender names a service instead of the process. And second, the receive a message from any process and return the process identifier, that is process ID of the process from which message was received. Here the process ID is defined as the process identifier. In above the send, the process addressing is also known as a functional addressing because the address used in the functional Communication primitives identify the server rather than the process. So with the two basic types of process addressing used in the communication primitives, we now look at the commonly used methods for process addressing. So first is combination of the machine ID and the local ID, such as machine ID at local ID. Here machine ID part of the address is used by the sending machine kernels, and the local ID part is a receiving process identifier. The local ID need to be unique for only one machine and cannot be generated locally without a consultation of the other machines. Here advantages of the method is there is a no global coordination needed for the process addressing, but it also has a disadvantages as it does not support the process migration. Second, link based process addressing. In the link base, the example is like machine ID at local ID at machine ID. Here the first field machine ID on the left identifies the node on which the process is created. The second field local ID at the middle is the local identifier generated by the node on which process is created. And the third field on the right, machine ID, is a last known location of a process when the process migrates to another node. Here the link information is used for forwarding message to migrated process. The link information can be the machine ID to which the process migrates is left with the current machine. And here's also drawbacks is that overload involved in locating a process may be large. And second is if node on which process was executing, that is the intermediate node, is down, then it may be not possible to locate the process. Third, location transparent process addressing. Both process addressing methods we previously described are non-transparent due to need to specify the machine identifier. The user is well aware of the location of the process. Hence, location transfer process addressing mechanism is more desirable for message passing setting. Here, centralized process identifier locator that maintains the counter can be used for this purpose. However, this is not reliable and scalable. When it receives a request for an identifier, it simply returns the current value of this counter and then increment it by the 1. Fourth, the two-level naming scheme. Another method to achieve the goal of location transparency in the process addressing is use two-level naming scheme for process. In this method, each process has two identifiers, a high-level name that is machine-independent name and a low-level name that is machine-dependent name. Such as machine ID at local ID is the example. Name server maintains a mapping table that maps a high-level name of a process of low-level name. Kernel of sending machine obtains a low-level name of receiving process from name server and also it catches it. When the process migrates from one machine to another, it only low-level name changes. It is also used in functional addressing, that is the explicit addressing. And this is method also not scalable and the reliable. So thank you.